Hello everyone, welcome back to another session of Verilog coding with me. So let's get started. So in the last video we have seen generate for loop for 100-bit binary adder 2. Now we will see for generate for loop 100-bit BCD adder. So here is our problem statement. You are provided with a BCD one-digit adder named BCD FAD that adds. So they have given us the module. We have to just use it in our code. So what is BCD? It is binary coded decimal. So binary, each decimal number is converted into 4 bits of binary number. So first one, first we have to write the wires. They should be of 100 bits because we are considering intermediate coutts. So there will be total of 100 coutts for each 4 bits. Means for each 4 bit there will be one cout. So for 400 there will be a total of 100. So January for I. So like last time, first we have to declare the first bits, or else it will create an error before for loop. So BCD F add is to 0, B3 is to 0, comma C in, comma C out of 0, C in, C out of 0. So where we have to declare the X because it is the intermediate C out, not the actual C out. So sum of 3 is to 0. So this we have got the one bit. Now we have to use the generate loop. Generate. In that we have to use for loop for I equal to 4 because we have already used 4 bits here. I equal to 4. I less than 399 means we have to use 400. Here we have to write I equal to I plus 4 because we are considering 4 bits of binary number. So in generate we have to use this colon and write the user defined name. Now we have to begin. It should be here at the beginning, not at there. Begin. So BCD, here we have to write user defined name even BCD F add A2 A of I minus 3 equal to I. Why I minus 3? Because suppose now if I is equal to 8, so it will be 8 and here 8 minus 3. Oof, let me write it once. It should be I plus 3, not I minus 3, I plus 3. Like here it will be 8 if I equal to 8 plus 3 11. So total of 4 bits. So similarly of B I plus 3 is to I. So scene will be the previous carryout of previous bit carryout. So here we have to write the wire X. So previous carryout should be written like this I slash 4 because we are using 4 bits minus 1. Why like this? Because suppose I is equal to 8. So 8 divided by 4 will be 2 and 2 minus 1 will be 1. So it will be the previous bit. Similarly, here we have to write X of just I by 4. And sum will be of similarly sum will be I plus 3 is to I. So that's it. We have to end here and end the generate. And after generating, we have to give the cout, the main cout of our assign. Assign should be used. Assign cout equal to x of 99. So let's submit the code. So as you can see, compilation process has been started, and we have got few errors on line 15. What is the error at line 15? So here we have used a bracket. So let's submit the code once again. So compilation process has been started. There are no errors till now. It is taking few time. I don't know, maybe network issue. Why is taking few time? We will resubmit the code. Let's wait for few seconds. Maybe network problem is there. Then we will move on to the code. So as you can see, the status is success, and this time they have not given us the timing diagram. I don't know why. So that's all. See, no mismatch, no mismatch. So in the next time we will be seeing about various things. This is the exams. I don't know. We will be seeing about the combinational logic.